Assalamualaikum warahmatullahi wabarakatuh. We are from Group A presenting silicon rubber polydimethylsiloxane, which is PDMS, a high performance silicon rubber. This study's members consist of 4 people: Muhammad Zikri Zaman, Amir Zafri bin Zuhamli, Muhammad Azim Azhari bin Abdul Halim, and Syed Muhammad Hasifdani bin Syed Nur Penama. What is PDMS? PDMS is a silicon-based polymer, known or popular with its flexibility, chemical stability and biocompatibility. Its unique siloxane backbone and material groups provide high stretchability with excellent optical clarity, thermal resistance and conformability. PDMS is ideal for flexible electronics and biomedical devices, enhancing like conductive filler, further expand its application in wearables, sensor and implants. This property make PDMS a leading material for next generation advanced technology.
Assalamualaikum warahmatullahi wabarakatuh. So I will continue the presentation. I will explain about why we use PDMS or silicon rubber as our material for the flexible electronic. So for the reason is it has a high flexibility and stretchability, biocompatibility and thermal stability. So the material can withstand about a certain amount of heat that produced by the circuit. So for the next reason is the softness at thin film. The materials in the picture in the slide is the soft electrode. This is the application of PDMS nowadays. And for the next reason is the material has optical transparency and hydrophobicity, and it is also have a modifiable for conductivity. So next we go to the limitation and advancements. First we go to the limitation first, which is the material has biocompatibility and thermal stability, which is weak to metal addition and low dielectric constant. And for the advancement that we can do is the PDMS composite, which is we can mix it with conductive polymers or nanomaterials, or we can do the surface treatment, which is use the plasma oxidation to improve the metal addition.
Next, we talk about PDMS physical properties. PDMS has a lightweight, flexible and transparent material which is widely used in flexible and stretchable electronic devices. It has low density, makes it comfortable for wearables application. It has high optical clarity, which is too ideal for optical sensor and display. Also, they offer thermal stability, which they have low thermal conductivity and high specific heat, helping the device to be cool. They also provide excellent electrical insulation due to low electric constant and high dielectric strength. More importantly, PDMS has highly flexible and resilient, allowing it to be stretched, deform and integrate into complex, conformable electronic circuit without losing its functionality. All these properties together make PDMS a key of material for designing stretchable, flexible and biocompatible electronic technology.
Hi, Assalamualaikum. My name is Zikri Rahman. So today I would like to share to all of you about mechanical properties of PDMS. PDMS is known of the high flexibility, stretchable and softness. One of main advantages is that its mechanical behavior can be easily turned by adjusting the mixing ratio of the base polymer and the curing agent. A higher crosslink density gives a stiffer material, while a lower one results in a softer, more elastic PDMS. As shown in table, PDMS typically has young modulus ranging from 100 kPa to 3 MPa and can stretch up to 700% before breaking, which make it ideal for flexible, stretchable application. It also has a Poisson ratio close to 0.5, indicating that it behaves almost like incompressible material. In addition, PDMS show viscoelastic behavior, meaning it can deform like both a solid and a fluid. This property is especially useful for application involve repeated movement for vibration. Okay, so now we take a look for the microstructure PDMS. PDMS is made of a flexible silicon backbone that silicon and oxygen atom alternating. With methyl group attached to each silicon, this structure gives the polymer change its mobility and lead to a very low glass transition temperature, around minus 125 degrees Celsius, so it stays rubbery even at low temperature. During curing, PDMS form a cross-linked three-dimensional network which gives it mechanical strength and elasticity. Its surface is naturally hydrophobic due to the methyl group, but it can make temporary hydrophilic using treatment like oxygen, plasma or ozone. This is useful for bonding PDMS to glass or other surface. So I think that's all from me. Thank you.
For fabrication and processing, PDMS is made by curing base polymer with silicon hydride agent using platinum catalyzed. The degree of cross-link controls the stiffness of the material. More cross-link make it more firm and less make it soft and flexible. We also add fillers like carbon nanotubes or silver particles to make it conductive while keeping it stretchable. To improve bonding, especially for metals, we use plasma treatment, which temporarily make the surface hydrophilic and improve adhesion during device assembly. So for application, PDMS is widely used in flexible electronics like wearable sensors and bendable circuit due to its stretchability and transparency. In biomedical device, it is used in skin patches, implant, and lab-on-a-chip system because it's biocompatible and easy to mold. Then, for soft robotics, it's ideal for building flexible actuators and sensors. It's also used in optics, coating, and as protective film, which making it truly multifunctional material across industries.
As conclusion for PDMS, we know that PDMS has a great elasticity, chemical stability, and optical clarity, making it indispensable in flexible electronic or soft robotics, and maybe in biomedical field. With challenge like poor metal adhesion and low dielectric constant exist, advancement in composites and surface treatment are effectively addressing these limitations. It is tunable properties and compatibility with fabrication process solidify PDMS as a cornerstone for innovative and it is resilient technologies. As research progresses, PDMS remains the material of choice, driving advancement in evolving industry like healthcare and next-gen electronics. I think that's all about PDMS that you should know. So I bid farewell and thank you very much for watching this presentation.